Cannot hear you.
Hi, can you hear me? No.
Yeah, now
Yeah,
it's
okay.
better. Hi.
Yeah. Do you want to do some introduction?
Yeah, I will do a quick introduction. Let's wait for a couple more minutes if people come, and then I'll introduce you, and then you can take over.
Okay.
Where are you in Helsinki?
I live in Tampere and this is my kind of home office where I'm working from. So
Okay. Okay, nice. Yeah, Tampere is the best city in Finland, according to some studies.
yeah, it's good and it's been kind of for the I think past 10 years it's been evolving in a quite nice way, in a way that there are new stuff, new buildings and not major
Yeah.
mistakes in the kind of infrastructure.
Did they make mistakes?
No, I think the only mistake they are now making is that they are creating this artificial lake in the Näsijärvi, which seems so stupid because there's like tons of free space uh, in Finland in general. Like it's not a big city, so there are like tons of space, and then they are filling up this lake in order to make buildings.
Ah, okay. Ah, that's a shame. Yeah. But it's I'm from Turku and the people here or Turku is trying to imitate Tampere. You know, you have what you have in Tampere, Turku is like at least 10 years behind. But yeah, Tampere is it's visionary. You have visionary people deciding about things. So that's pretty cool.
Yeah, it's good. It's a nice city. And still, like
Great.
there is still the kind of the old industrial center, which is kind of left untouched and renovated, kind of like in a nice way. The
Yeah,
Finlayson area.
that's right. Yeah. Good. Okay. I think we can get started. So yeah, we have Mr. Santeri Salonen here today. I'm recording this session on Santeri's permission, and he will be talking about machine learning kind of in production systems. So this talk is for business students, but Sander is very versatile and he has business background and also technological know-how. So last week we had actually Mr. Tommi Vilkamo from Relex Solutions, who is, I'm sure Santeri knows him at least from LinkedIn, and the story is the same. I hadn't met Tommy, and I have not met Santeri before that, but I have been following his posts for many years, and they are extremely good stuff. So he started posting, or when I started following you, Santeri, you were posting a lot about analytics, and I was like, okay, this is cool stuff and cool ideas. And then more recently, you have shifted to post about AI and the AI opportunities. And I saw from your profile that you have co-founded a company called hetki.io. So in Finnish, hetki means it's a moment.io, we could say. So, and that company uh, provides executive AI skills delivered by AI natives. That sounds very cool, Santeri. So maybe you could also tell us a bit about that and maybe about yourself. But yeah, please take it away and looking forward to learning new stuff.
Yeah, thank you. Yeah. If I quickly kind of start with the observation that you made that yeah, I'm actually part of kind of two startup companies at the moment. In this, there is this hetki.io, which is basically a Finnish Helsinki-based company, and what is our mission is basically to help like senior leadership to understand AI and also use AI in their own kind of leadership as a leadership tool. And we are currently in a stage where we are kind of trying to make the business scalable in a way. We have customers, and we've been kind of developing the kind of the product for roughly a year now, but now we are kind of in a stage where we try to make it an actual business. And then there is this other startup which I'm working with, which is basically I'm a little bit less involved, but it's operating in Nigeria, in Lagos, in a healthcare area industry, and there my role is like really more like a technical role. Then I also work as a kind of like a consultant, but now like I've been having less time for clients, so basically but still like dividing my time between these three things, that being a consultant and then with these two startups. I don't know how to use actually this Zoom, so I need to figure out how to share my.
There's like a share button at the
Okay.
bottom, and that you can use to share your screen.
Yeah. Okay. So here, I think this should work.
Yes, perfect.
Okay. Yeah. So as Joni mentioned, the topic is ML in production, and I was kind of thinking how to approach this. There are, I think, if we would kind of, and thinking about the kind of the audience, that we are not really interested in maybe in the actual technical details that much, but still, like when we are discussing about production, then that typically refers to production environments, which are actually the area of the IT function of the companies. So even if the kind of the solution is not like if we need to do something, or enable some feature in actual production service, then we kind of have to deal with the IT in some way. So I tried to include that stuff here as well. But the kind of the overall goal is to kind of just provide some sort of a broader understanding about this topic, and not go into too much technical details. And I just kind of created this agenda. First, different ways to think about ML in production. What does that actually mean, and in what context, and at what time, basically, that it might mean different things. And then let's look at a little bit like more like how to actually make use of machine learning models. And then I wanted to kind of go through one example, which is something that I've been working for the past year, and we kind of started with the proof of concept, and then with the test with an actual customers, and then we are now in the stage of migrating that solution to the client's existing infrastructure. So that's basically the example case there. And then if there are any questions or a discussion that we want to have, and I don't know exactly how long this would take, but I'm guessing it takes something like a little bit, maybe 1 hour, 15 minutes or something like that. And as was kind of introduced before, like what we discussed already, like working as a consultant and do startup companies. But I also been working with like in different types of roles, like business, marketing, technical roles. And for the past years, I've been mostly working with different types of data engineering and like generative AI projects, mostly since there was this in 2022, there was this OpenAI released the API, which enabled all kinds of different things to be done with the generative AI. So I've been doing those types of projects. I also have this kind of like Google Cloud Professional Cloud Architect certificate, and I've been also using quite a lot of like Amazon cloud, and now for the past month or so, I've been also I needed to kind of also learn a little bit Azure, Microsoft Azure as well. But that, my actual like academic background or degree is from social sciences, so I like to kind of think a little bit like from broader angles as well. And this image is actually generated by AI. It's an image of me, but it's generated by AI, and I will tell a little bit more about that later. So let's start with the actual content or actual topics. So different ways to think about ML, and then I just wanted to kind of add this as a starting point, that if you go and Google, for example, that machine learning project or machine learning workflow or something like that, then this is something that you would probably get. So you would get these like steps that first you need to find the data. You need to kind of have the data that you will do your training with, and then you need to prepare that data. Then you need to actually do the training. Then evaluate the results. There is typically this. You have a data set, and then you divide it to training data set and validation data set, and then you kind of train your model on the training data set, and then you validate or evaluate the results against the validation data set. And once you're happy, you might kind of, before you are happy, you might need to fine tune the parameters and even compare different models against each other and so on. But once you're kind of happy, then you have a model, and then you would have the question, okay, how to then deploy this? And that deployment means, okay, how to deploy it in production, how to actually start using it in some sort of a business process. But then I just wanted to kind of add this question or this thought here that what we would get out of something like this is basically a model that can generate a prediction. It might be a true or false prediction, or it might be a class prediction, like if this is a car, or if this is a motorcycle, or if it's a bicycle, for example, or something like that. So then the question actually is that what problem would that prediction solve? Is there some kind of a problem that we can just solve by predicting something? And in some cases there is. For example, if you work with if you are a bank, for example, you might have a prediction about if you want to give a loan to the customer, if the customer will pay back that loan or not, and that prediction might be immediately useful. Or in the context of healthcare, for example, you might have X-ray images, and then you could automate predictions that if there should be further investigation or something like that. But in most cases, these types of kind of problems that immediately benefit from this type of a prediction, they are kind of like not easy to. It's probably not too easy to find new problems. They are like these existing problems, and then you could just develop a better model. But this is kind of the question, that we need to have some sort of a broader context, a business problem or something like that, that the prediction would actually solve. And if you think about what types of problems we nowadays solve with machine learning, there are tons of these. So I added examples. If you have like a images or video stream or something like that, you could identify objects, or you could identify humans from the picture. You can do machine translation. You can have some sort of a recommendation system if you're on e-commerce, or if you are Netflix or something like that, you want to recommend movies or products. that uses machine learning to learn about the preferences of the users. And then I added some other things as well, like if you want to evaluate if some content is safe or if it follows your company policies, you could do that automatically with machine learning. I'll just drink a little bit water because I'm so I can keep my voice maybe better. But yeah, identify letters, numbers from images, predict customer churn, transform text to speech, generate text, generate images, fraud detection, forecasting something, forecasting profits, for example. All of these are kind of problems that nowadays we use machine learning to solve these problems. But then there are also like existing solutions to these problems. So if you would want to solve something like this, you wouldn't probably want to follow the machine learning workflow where you go and, okay, I need to collect images, I need to train a model, I want to evaluate that model, I want to deploy that to production, because there are already solutions that solve these exact problems. So you could just basically start using these tools without worrying too much about the data preparation and data gathering stuff. So then the question is basically that when does it actually make sense to develop your own machine learning solutions? And today, basically, if it might, the answer might be different if we would ask this 20 years ago, or if we would ask this 20 years from now. And I just added this one book, which is I think pretty good book from the point of view that it looks at technology from this evolutionary point of view, that whenever there are some technologies developed, then those technologies will be the building blocks for next technologies. So basically the idea is that you wouldn't kind of, if there is some technology, then that technology will be like a subcomponent of the next technologies that will be available or will be developed or invented in the future. And now, especially with the AI stuff and with machine learning, there's been so much development in the past, let's say 10, 15 years, that whatever made sense like 20 years ago or 15 years ago doesn't really make sense now, because the environment has changed so much. And what this means from a business point of view is basically that I just added here that this kind of a tool, basically, this is like some sort of a consulting framework or tool that called worldly mapping. But basically the idea here is that we have some technologies that are kind of born in this genesis phase, and then once the technology is born, then what happens next is that then people start experimenting and building their custom solutions with those technologies. So let's say there is some machine learning model that's researched and then it's kind of published. Then in the next few months there will be some implementation, like custom implementations of that technology. And then once time goes on, then there will be products available in the market that will incorporate that technology as part of the product itself. And then when the time goes on still further, then it becomes a commodity, basically like an electricity, that you can just basically start using some technology without worrying at all how it's produced, or just basically start using it and use it as one part of some other solution. And this is really important in a way, because if we are kind of, for example, Googling what is a machine learning project, or how to deploy machine learning to production, then typically the discussion or the documents or references would assume that you are talking about this kind of custom solution that you want to implement. You want to kind of train your own model with your own data and then go to production. But then, but actually, like I think most of the uses of machine learning nowadays are in this product or in this commodity where we just kind of start using something without worrying too much about the training or the models that are kind of behind the scenes operating. And maybe to kind of clarify this a little bit further, if we kind of rewind back to 25 years from now, it was 1998, and there was this company called Amazon.com, which wasn't a big company back in that day, but it made these heavy investments in research and development, and they actually launched this recommendation system. And they actually had this patent for this item-to-item based collaborative filtering in 1998. And it enabled them to do these product recommendations on a large scale. And of course, back in the days, the e-commerce or the business wasn't too big, so it wasn't that significant. But after those years, then this is from McKinsey. McKinsey, they estimate that 35% of Amazon.com revenue is generated by its recommendation engine. And it's like a result from those early investments that they made on the research and development, and they kind of believe that this is something that will be the kind of the future. And they took the role. They actually published papers. They did the research. They filed their patents for the recommendation system. So it was the recommendation technology, the machine learning technology, is what it was like being born at that time, basically. So it was like a different game. Now, if we move to today, then if you are now an e-commerce business and you would want to start using recommendation systems, you wouldn't want to follow the Amazon way, because it doesn't really make sense to now start developing your own system for product recommendation. You can just start using something that already exists on the market. Maybe pay some monthly fee for that, but you don't have to invest millions in developing your own algorithm for the recommendations. You can even start using Amazon's algorithm. Amazon, they actually have this in their cloud service. They offer their own personalization or recommendation engine for everybody to use. So answering, for example, this question, how to develop a recommendation system for an e-commerce, the answer is totally different if it was back in the days in the 1998 and what the answer should be now, because now the answer should be that you just take something that's available on the market and start using it in an intelligent way, instead of going to the machine learning workflow and gather data and stuff like that. So just to summarize basically the ideas here, that if you would want to actually develop some sort of a custom machine learning solution, it takes time and resources, and you need to gather data and develop a model and so on. But from the business point of view, unless we gain some competitive advantage from the investment, it doesn't really make sense to develop custom solutions. Of course, we might want to still develop something from, if we just want to kind of learn how to train a model and so on. But from a business point of view, it doesn't really make sense to invest money into something that doesn't really bring any competitive advantage if there are already existing solutions in the market. And machine learning, AI, they have been evolving so quickly in the past years So basically, there are lots of these existing tools that are available in the market. We can use existing products. We can just start using APIs for different things. For example, image recognition, speech to text, text to speech, recommendations, anomaly detection, basically any type of a use case that we kind of showed, they are at least in some form available as a pre-trained, ready to use tools. And with these pre-existing tools, we can focus more on solving a business problem and less on developing these custom solutions or custom models or training the models ourselves. And I think this is also, at least from my point of view, because I'm not really, from an academic point of view, I'm not really machine learning expert or artificial intelligence expert in that. From that point of view, I'm more like an implementation type of a person. I'm engineering type of a person. So this is also what I maybe a bias a little bit here, but I really think that it's more important that we can kind of start leveraging these models quickly as possible and spend maybe less time on the fine tuning the models and finding the best predictions. Okay, so that was kind of the context or the background, and now how to actually make use of machine learning models, and the focus here is on the kind of the production states, how to kind of move from the model to the production, and what tools, what solutions there are available for that. Maybe again, like we need to, this is more from the IT architecture point of view, but this is a really important concept here. So API, application programming interface, what it means basically that there is just some endpoint. You typically it's just an HTTP endpoint URL that we can call and then basically use that endpoint to integrate with some other service. And this is like a modern corporation. They have wide range of different business software, and they communicate with each other using these API endpoints. And from the ML machine learning point of view, if we want to have some sort of a model and actually use it in some sort of a business process, then what it typically means that the model needs to be available through some endpoint and like an API endpoint that we can call to use the model and create these predictions. And it doesn't really matter if you develop your own model, train your own machine learning solutions, or if you just use something off the shelf. You typically need to have it available as an API, so it's available for integration with other systems. Say, for example, if you have a model that can predict if customer will churn, will kind of stop being a customer, and then you need that prediction in some CRM to automate some kind of a message, for example. Then the solution for that is to have the churn prediction model, so in a way that the CRM can actually integrate with that model and get the prediction based on some criteria, and then the CRM can perform actions based on the prediction that the model will give you. So it's basically just how the modern corporation they kind of architect their software in a way that they integrate with each other and talk to each other using these APIs. And if we can do the same with the machine learning, we can just provide an API that can do these predictions, then it's easier to start integrating those those models into actual production workflows. And this is where for these cloud services, and I took this example from Amazon Web Services, but they come really handy because they kind of offer this type of workflow in a package. So there is this tool called Amazon SageMaker, for example, that basically enables you to have your own data, trade your own model with your own data, do the evaluation, but then just basically with the push of a button, deploy that model as an endpoint that can be integrated with other products, and they kind of offer that as a workflow or as a service inside the Amazon Web Services cloud. And of course, like Google Cloud, Microsoft Azure, they have similar tools for deploying these custom models. But this is basically the idea here is that this is something that you would actually do the custom development, you would have your own data, and then you would do your own training and do the kind of the full machine learning workflow, but you would actually do it inside this cloud environment, which would allow you to then just basically deploy the model with the push of a button. And then you would have things like version control. If you update the model, you can update the API endpoint as well. And then let's say this is again like the churn prediction model you run on the SageMaker, then you could just basically integrate the endpoint to your CRM system and start using that prediction. But as I said in the beginning, that in most cases you don't probably need to actually go there and start developing your own models in order to benefit from machine learning. There are lots of these pre-trained models, which basically already offer an API that you can just start requesting the predictions for your based on your input data. And this is just a screenshot from Google Cloud. There is this Vertex AI, which is basically just a brand name for their all different AI tools that they offer. And this is just a screenshot from six different pre-trained ML model that you can just basically start using right away. And just a few examples here, like a product recognizer. If there is a GTN or UPC code in the product, you could identify it automatically, or if you want to do some image modifications and stuff like that. But there are lots of other APIs that are kind of already available, and you would, in this case, you wouldn't need to worry about the model performance. In a way, you could just basically trust that the service provider, in this case Google, would be responsible of that, and your role would be just to kind of think what business problems we could actually solve with these predictions. And most of the, like I said, like most of the possible use cases you would think for these predictions, they are kind of already covered by these different APIs. Then now there is this concept of basically deep learning, but basically the idea here is that with deep learning there is these different layers basically, and then you have some sort of a pre-trained model that can do something. For example, if you've been using ChatGPT, there is the kind of the generative AI is a deep learning model that can generate text and responses based on your prompts. And then there are these image generation deep learning models, for example, that can generate images based on the prompts. But But here the idea here is that we are kind of fine-tuning a layer on top of the pre-trained deep learning model. And in this example, this is actually an example from I showed you the image of me that was generated by AI. So it's basically this Flux LoRa model, which can generate photorealistic images. But then I created this like a trained additional layer on top of the base model or on top of the foundational model, and teach the model with just a few examples of my images. And then after that training, it can actually start generating images of me instead of images of, or in addition to generating images of everything else as well. But now it kind of knows my name and knows how to generate my image. And then I could even train an additional layer. I could, for example, teach the model with pictures of my wife and my kids, and then I could start creating like family pictures or whatever. But the idea here is that it's really kind of simple in a way that you can just use the service, and then you just have your pictures, and then you train an additional layer, and then with the push of a button, you can basically create a deployment from your model. And then you can start using this prediction, this image generation model as an API, and I could have an API that generates images of me. I don't have any use case for that, but just then kind of as a concept. The one additional kind of important factor here is that we are actually deploying these predictions are quite resource heavy, so it's actually deploying this on a hardware that runs 8 pieces of NVIDIA A100 GPUs, and these I don't know if the exact price, but I think it's something in the ballpark of 20,000 euros per piece. So it's like a quite expensive machine that if I click this button, it kind of creates me quite expensive hardware. But the point here is that I don't even need to pay for that hardware unless I actually use the API endpoint. So these types of services, they kind of provision the hardware whenever needed. And if I just use it once a year or once a month, I don't pay for the full month, I just pay for the seconds. And these types of cloud services, they actually enable us to use these predictions, even if we don't kind of want to invest in the hardware, which is pretty costly now with these deep learning models. Then another example, this might be more familiar with everybody, that like the ChatGPT, for example, that you can just basically go to the ChatGPT and start using the foundational model and get those responses. But what we can also do with the GPT models and with other large language models as well, but using the GPT-4 here as an example, we can do the same thing as we did with images. So we can basically take the base model, then have this training data set, which doesn't need to be the full data set, just basically have enough data for the model so it can learn something new. For example, if you have a business, you want to kind of adjust how it speaks, you want to teach some core business concepts, then you could do this training layer on top of the base model and start using your own model. And it enables you to kind of use these models with the lower cost, because then you don't need to have these long prompts, and you might be even able to achieve good performance with smaller models, because you have your custom custom training on top of the base model. So just to summarize, if we want to develop our own solutions, then there are these tools that we can use, use for the purpose. So we can kind of pre-plan how we deploy that model to the production, and that happens using the API approach. And tools like Amazon, they have this SageMaker, for example. But then there are also like tons of pre-trained APIs for lots of purposes. So if we just use these, then we can kind of skip the need for doing our own custom training and collecting the data and evaluating the models and everything. Then if we specifically think about deep learning models, and I think mostly about generative AI, then we can use, for example, for image generation, we can use services like Replicate and run these open source models and train custom layers and then just deploy those as APIs. And then services or products like ChatGPT, they are also available as these API services. If you go to the kind of the developer side of OpenAI platform, then you would get access to the API and you could just start using those predictions as part of your own solution. Okay. Then for the final part of the lecture, I will go through this example case, and the name here is Enterprise AI Assistant. I have this kind of summary of what was done, and you can just read that through. I won't read it word by word, but if you just take a few minutes to, I think 2 minutes to read that through, and I will drink a little bit water so my voice will stay clear for the next minutes as well. Okay. So basically the problem or the business problem here is that the company wanted people to find their kind of support material more easily, and they believe that, okay, maybe if we just feed this data to an AI, then the AI would be able to answer customer questions without the customer needing to browse through website or do searches and stuff like that. And we also did in addition to the solution, we also did this kind of like a A/B testing on the website to actually see if users actually use that new tool, the AI powered tool, and how it was kind of performing against the traditional website experience. This is a simplified version of the architecture. So if you read the previous slide, there was this idea that there was this ETL pipeline, which is extract, transform, load, which is just basically a term that people use in data analytics, data engineering circles. It's not. It's just basically a fancy term for moving data from point A to B. And in this case, the extraction happened from the website. So we just had this basically a bot that went to the website and read through all the content from their info, like product information center, and then the content was transformed in a way that it was kind of split into parts. So we would just have like 200 words per piece. Then after that we would get, there is this like now we would be next we would be using the API to get the large language model API, but instead of getting the like this chat response, we would be using the LLM to get the vector representation of the text. And what this practically means is that there is a way to kind of transform text to numbers, and I would go into the details, but basically what happens is that every word has this vector representation in this huge vector space. So there are in the open AI case, there are like the vector space is something like a 1,500 plus dimensions, and then you get like a response that, okay, this piece of text, what's the vector representation of that text? And the idea here is that using the vector representation, then we can, after we have that, we can kind of search with similarity. So if you have a, if you know how vectors behave, that you have a vector, and then you can actually count that how close another vector is from that vector that you are searching for. And I think I had some links, but now I can't really see the let me see if they're actually here. I will show you quickly this. If you're, let me see. If you are interested, you probably don't need to understand this fully, but I think this is something that's quite interesting. If you just, for example, Google king plus woman equals queen, you get something like this this article here. Okay. Can you actually see my screen now? The MIT Technology Review. Yeah. Okay. So it's basically this idea that there is this computational linguistics, and then you can actually do this kind of turn words to numbers, basically. But I think that's a topic that we can't really go too deep. But the idea just to communicate the idea here that we would get this turning the text to numbers, basically, and then storing that text along with the numbers to a database. And this is kind of the back end or the data pipeline of the solution. And then once we have that in place, then we have the ability to actually create this user interface that when, okay, now a user comes to the website, they are shown this chat. And then again, now we use the API from the LLM, but now we use it to generate responses. And we also use it to generate these search phrases. So it can actually, the LLM serves two purposes. It basically responds to the end user, but it also goes to the database that we just created and stored all that information, and then it can search things that answer users' question the best because of the transforming the text to a vector and then basically being able to use the vector similarity to retrieve the best matches from the database. I don't know if you've been using if you use something like at least when I was studying university and then I did some research trying to find books from library and stuff like that. It was really painful because you just had to use those keywords, and if there was no match, then you wouldn't find the best results. But this type of a search works a little bit differently because it searches with meaning, so it can always find matches. So basically, if you just an example that if you have something like a Snickers bar as a product, but then someone searches with chocolate, but your product description wouldn't say chocolate, it would just say Snickers, then the vector search would be able to actually retrieve that product because it knows that Snickers bar the meaning is close to chocolate. So it would be able to retrieve that information from the database. So that's the idea of the vector, using the vector database in this case. And there are like specialized tools for that, but you can also use more traditional database and just turn it into a vector database by using extensions. But yeah, from the user's point of view, the end result looks roughly the same as you would just go to a ChatGPT. But then from the business point of view, we can actually control that the chat assistant offers only answers based on the customer, based on the client's own information. And I actually had here this like an explanation what are the embeddings, and this is like a simplified example that imagine you're trying to describe different types of food to someone, and these are the dimensions: how sweet, how spicy, what's the texture, what's the temperature, and you might have pizza and then you might have ice cream, and they would have totally different vectors in this this four-dimensional space. But then if you would have pasta, for example, then the pasta would be actually closer to pizza than the ice cream. So how to actually kind of move to production with something like this? And as we kind of discussed in the opening slides, the prediction alone typically isn't the solution, but you need to have other stuff in order to actually solve some business problem. So in this case, we would have the user interface. We would need to use multiple, like the APIs multiple times, have these other infrastructure, which was the vector database. So it's not simply about having a machine learning exposed as an API, but we actually need to develop some like a little bit more complete solution to some problem. And this was the kind of the MVP. So there is this term minimum viable product. It's coming from this, I think, from the kind of the startup jargon, basically, that you build something that's actually, it's not just a test, it's not just a proof of concept, but it's actually something that users use and they kind of find valuable. And then we had this, in the beginning, we had this like MVP project where we just wanted to move to the kind of not in a way to production, but just kind of as a test, basically, that we would go to the actually run this tool on their website for a few months. For here in this plan, it was 1 month, but we actually needed to extend that. And first, we kind of defined the business problem. We ensured access to the data sources. We did some internal testing, and then we had the chat interface, and it was connected to the database, and then we were able to run this interface or run this as a like a feature on their website as an A/B test for 2 months. Then we kind of removed the feature from the website and then did this analysis, like how did it go, did people like it, and so on. And the results were quite good, so the company wanted to then continue with the project. So basically, the next step was then to, okay, now we actually need to implement this in production. And what in this context this means is that they had their existing IT infrastructure, they had the ID function, and they had made decisions to use Microsoft Azure for everything. So we would need to migrate this solution to run on resources that are inside their own Azure environment. We didn't have any kind of communication before that with their IT function, so we needed to kind of create connections there and then establish ways of working, how to actually deploy things on their Azure infrastructure, and what role we would do and what role would they do, and so on. And then there is actually a typo here. I'll just fix it. But then we needed to, because they wanted to kind of have this template that they could then use for other projects as well. So we would need to write this code there is this term called infrastructure as a service. So basically, it just means that everything that the solution needs, including the infrastructure, including the database, including the OpenAI deployments, the kind of the models, including the other stuff that's needed, all of that is part of the code. So we don't kind of go to the UI and click stuff, deploy computers, but we kind of just deploy it using a script. And then have like a process if we need to update the code. How does that happen? Does it happen automatically? Then if it actually runs on their website, then we need to have some sort of a monitoring and alerting system. If something goes wrong, we need to have a process for reacting to that. Then there needs to be this additional testing, and then next step is basically setting up a team that's responsible for ongoing development, because they also had these additional like ideas for how this should work, and those were kind of scoped out in this test phase and moved to this production phase. So after the kind of the migration to the production or their own Azure environment, there would be this continuous development of this tool. So it would start serving other use cases as well. Good. I think I was actually a little bit faster than I expected, but still on the schedule. But I think how does it go, Joni? Can we have some sort of a discussion or like a questions or?
Yeah, that would be super good. I actually noted down several questions to you, Santeri, but if students, I did it because students are nowadays very shy to ask, so for whatever reason, so they don't tend to much ask. But I have questions, and I think it was a very good presentation and interesting case as well. Do you have any questions, students? Just feel free to ask, post in the chat, or just enable your mics and ask. This is a good opportunity to learn how ML products can be actually deployed in real life, as Santeri has experience on this. Okay, Maria, everything is clear for Maria. This is good. Okay, so feel free to ask, but in the meantime, I do have a few questions. So, yeah, Santeri, you mentioned that your background was in social sciences, and I was looking at your introduction slide there. So it looked like this unicorn type that Tommy was talking about last week, that has subject matter expertise, but also has technical expertise, and then has analytical expertise. So the Venn diagram, and in the middle is kind of the unicorn. He was saying that there are no such people, but it seemed like you have a very interesting path, because most of the people would come from computer science background, and they would not usually have like this kind of, you mentioned, broader perspective. So yeah, what kind of led you to data science?
That's a good question. I think I've always been kind of a nerd in a way, and I did like when I was younger, I did these like websites and stuff like that. But then I kind of just started. I went to the university, and my main subject was international relations. But then to fund my studies, I started creating these affiliate websites at some point. And then that kind of just stick during the studies. And then when I kind of graduated, then I was thinking, okay, now I should probably start to work with something for real. And then there was maybe less opportunities in that those areas which I had like the study experience or the kind of the academic degrees, but then using the kind of the experience I was doing like search engine optimization for the websites. So I was kind of really good at that, and I was offered a job as a like a digital marketing consultant, basically. So then I started doing that, and then back in the days, the web analytics wasn't that big yet, but then it kind of started to grow, and then we formed this analytics team on the company. And then I was, because I've always been kind of using lots of data for different purposes, so I kind of joined that team, and then I ended up kind of leading that team in the company. And then I was actually traveling to Helsinki from Tampere on a daily basis at some point. So I used all the train like there was this 1.5 hour train trip back and forth. So I used all those to learn basically programming. So then I started to use the programming in the data to answer those data questions. I kind of started doing data engineering a lot more, and then I quit my job and started working as a consultant. And as a consultant, I've been mostly working with these with these technical projects, like data engineering and so I don't know if there is like a clear. I think it's just kind of following the what's I've been trying to do stuff that I kind of enjoy basically.
Yeah, oh, that's super cool. Super cool trajectory, and yeah, I think it's very inspirational. It shows how to go from kind of developing affiliate websites and then getting hired as a technical search engine optimizer and going into analytics and so on. It seems like you have like rediscovered or let's say branched out to new topics. So definitely these seem to be like important transferable skills that you're sort of curious and want to develop yourself, and then your interest in technology that sort of gives a general direction. But how did you end up specifically in ML? Like when did you? Because there's sort of like now from Santeri's journey, we can see that it's like stepwise. He starts from uh, something like websites, and then he moves into more and more tech, and he learns new stuff, and then he learns eventually he teaches himself programming, and this was before ChatGPT, so it was harder. Nowadays students can learn at least to run the code and generate the code because the syntax is handled by uh, the AI basically. But so he learned that, and then gradually, but there's still a jump from going from programming for analytics and data pre-processing to ML apps, and what you sort of. So how was that leap?
I think there are kind of two different things, or like key kind of insights, or how would you call those? But when I was working with the analytics, and then I had really good clients, and they were kind of wanted to do things and explore things in ways that were probably that available, like just by looking at the data. So, for example, in with one client, I built this kind of like a simulation that if we take all your website data, and they had this appointment booking website, they like a big one of those big healthcare companies, private healthcare companies in Finland, and they you go there and then you find a doctor, and then you book the time, right? So we build a simulation of that basically, and then we tested that if we add this feature on the, like there is this what if the customer doesn't find free times, what if we add this notification that okay, you can find the next time from some other doctor or from some other location, and then we kind of simulated that what if impact it could have on the conversion rates. And that simulation was kind of the first machine learning thing that I just kind of ended up doing, because I was trying to solve the problem, how to kind of, and then I found like okay, you can actually do it by building this type of a model that can actually learn from the data how the interactions go. And I think that's the kind of the in the first step I was just kind of solving the business challenges. I had the data, and then I kind of just started solving things, that's by using that data also for building these types of models, or like it was, I think it was mostly about just not so much about the models themselves, but they maybe more about automation, and in this case, for example, developing the website and so on.
Yeah, that's super cool. So, but what would you give as a tip for a lot of the students because they start from zero? So there's the cold start problem, and especially a lot of the students in marketing are kind of they might be a little bit afraid of like technology and all these concepts. And you having gone through it, you probably know that okay, there's nothing to fear, right? But in the beginning, um, did you feel like something was kind of
I
um, overwhelmingly difficult? How did you cope with that?
I think I have the kind of I've been lucky to kind of work with the kind of with the marketing and business people mostly. So uh, in a way, I've always kind of had the role of being the kind of the technical person in a way that I know, and then I just kind of extended on that in a way. And but I think they are like from especially from this AI point of view, we are kind of moving to a direction where this AI is not really about technical solutions anymore. In a way, it's more about there are these tools, and then it might in some cases I've kind of noticed that it might even be a problem if you are kind of too deep into the technical space, because then it
Mhm.
might you might not have the kind of the op- open enough mindset in a way how to apply these tools in a kind of solving actual problems. So I think that's one approach, that you actually want to solve some problem,
Right.
and then you just kind of push to solving that problem. And then if you find out that okay, this problem could be solved with some sort of a technical solution, then uh, you probably have the interest to actually start figuring that out. And whatever your kind of, if you want to do it yourself, or if you just need to kind of have the shared language with some developer in order to figure out how the or kind of communicate what you want, then even in that from that point of view, it's kind of important to know enough technology to have at least a shared language, so you can kind of communicate what's needed and what's critical and what's the kind of the business problem that needs to be solved. So I think that's uh, even I think that's even more important than being able to do everything by yourself in a way. I think for me it's more like I just enjoy doing stuff myself, so that's why I do it. But also that being able to talk with different types of people, I feel that I have the kind of the capability to talk with if we need to talk about technical specifications with developers, then I have the kind of the trust that I can do that. I can kind of be at their level, and then if I need to talk about business and the kind of okay, what objectives we are actually trying to achieve with this solution, then I can kind of adapt to that as well. And I think that's more important than being able to do everything from a technical point of view, or knowing everything from a technical point of view. I think that's also my kind of in a way downside, that I kind of want to do too much myself in a way, that then it kind of limits my ability to I spend too much time on doing things myself in a way.
Yeah, but it sounded you also do a lot with the team, and this is the kind of profile actually that is kind of ideal. So Santeri's profile is the one that can bring there was a video that talked about analytics translator that kind of was similar to what Santeri was describing, someone who understands the technical side, at least, the concepts and can speak with developers and engineers, and then, but also understands the business requirements, so can talk to executives, managers, and sort of translate the business problems into technical problems. So a lot of it seemingly deals with us trying to understand real problems in the world and then just technology is literally just a tool. Whereas often computer scientists, they start from, I want to apply this nice framework or library or algorithm, and now I have the, I have the hammer, let me find the nail. It's kind of different approach. But a lot of the stuff that you mentioned, Santeri, was the same that Tommy also talked about last week. Like he said that you need to fall in love with the problem, and that's actually more important than kind of fall in love with the solution or thinking about the solution, because through that problem you really kind of, if you understand the problem really well and you're really passionate about solving it, then the solution side is sometimes even a bit easier. And then the shared language, which you mentioned, was also mentioned by Tommy, that you need to have a foundational level of understanding when it comes to like these difficult technical concepts, so that we can cope with the data scientists and technical. It was the same also for me. I also worked a lot with freelancer machine learning engineers and programmers, and through actually just through these interactions, actually you can learn a lot because you can ask them and they're happy to explain, to share knowledge, and then gradually you learn to understand more about the concepts and you learn to understand more about their way of thinking. So this is a lot of this can be learned by just kind of being curious and exposing yourself, or somehow ending up in situations where you are like, exposed to technical stuff and working with technical people. So then, what I think you provided a really good angle there, Santeri, about the when to develop your own model versus when to use API-based services to in combination to build something. Um, so um, that was a really good lesson for the students, and it's kind of like a unique angle that I didn't address in this course so far. So, but it's kind of like a fundamental thing really nowadays, and I think your explanation of how technology is always built on top of the previous technology was really enlightening as well. Because yeah, that's a lot of the even if we build the custom solutions, the tools that we use would be most likely based on open source software
Yeah.
and libraries like scikit-learn and stuff like
Yeah.
that. So we don't have to reinvent the wheel. So this is kind of a great aspect in AI product development nowadays, that there are all these tools, whether you're building sort of a classical machine learning application where you develop your own models, or then more of like this um, combination of different services. And I think, well, what do you think? Like, how much has Gen AI changed that? How much has it changed, this idea of using pre-existing services? Has made it even easier, or how do you feel about it?
Yeah, I think it's a game changer in a way that at least like for me, when I never kind of considered myself an machine learning expert or AI expert, uh, and I don't really kind of even want to go into I wouldn't want to go to a role where I actually develop my own, do my own training and do these models and stuff like that. But once the OpenAI released the APIs, there was the 3.5, 3 or 3.5 was the first. Was I think the 3 was first.
Mm.
But the APIs were released, and you could just basically start integrating those responses to anything. Uh, and just to, if you think about it, what the you can kind of go there and have a chat, but the point is that it's basically still a prediction. So it's a prediction that based on this input, the generative AI predicts that the answer is this, and you can kind of use it. Of course, it might be a little bit costly to use it for
Hmm.
uh, other purposes, like but you can theoretically just use it for doing any type of a prediction. So, for example, we in our use case, we actually use it to predict if this search if this in the use case that we had the enterprise AI assistant. So the user would start the chat, and then there would be this model that would actually look at the uh, chat messages and then basically predict that if I need to do the search to the vector database or not. So it kind of looks at the message and then uh, it do we need to just answer to the user that there's no need to actually do a new search, or do we need to do a new search? And if you think that you would actually develop some kind of a custom model for this, that when to do searches to the vector database, it would be quite difficult thing. But now with the OpenAI LLM endpoint, we can just basically provide these functions that call this function whenever you predict that there is this need to retrieve new stuff from the database. And also, I've been doing some testing with this. There is this concept called generative UI, which basically means that you, instead of having like a website, for example, a web app, instead of having these components kind of populated, you start populating them on the fly based on the user prompts, and then it's still like a little bit like experimental. But if you there is this one company called Versal, which is kind of advancing this, that they are building this ability to, for example, stream those components to the user user interface based on different types of prompts, and you can do things like buy, for example, vacation or flights or something like that, with this kind of like a just natural language basically, and then you would be provided with the confirmation checkbox, for example, or something like that, that you can just then, or if there needs to be some kind of a credit card you need to add, then that's kind of provided to you when
Yeah.
just when you need it basically. And
Yeah, that's I'm personally looking forward to that because yeah, for example, this travel planning is annoying, with
yeah,
all those filters and selections there, and then not always it like they don't always have those filters that you want, but in natural language,
yeah,
you could sort of combine it with the model's general understanding of, let's say, destinations, and with then structured data about flight duration and so on, and yeah, then really I'm looking forward to that. I'm amazed we still don't have it because sort of the infrastructure is there, and like you said, authentication and payment could be built in there, and but yeah, still it seems like we are I think it will be a killer app for sure, because who wouldn't like to buy just directly from ChatGPT? It can, or any type of LM or chat, because you can see it can show you the products actually, and if you want, you can go and click on the link and go to the website. It can summarize reviews, give quick summary of pros and cons of the product, and then again help with all this kind of navigation. Might be that some people still enjoy actually the shopping experience of, scrolling and exploring products. Maybe like when it comes to things like fashion. Um, but in other use cases, like I think travel planning is a good example where it's so difficult to, at least even for me, I find it so difficult. I would find it much easier to just tell this chat what I want to travel and what are my sort of wish lists, that direct flight and price
yeah,
range is this and stuff like that.
yeah. I think there will be lots of lots of these kind of, it will kind of, that was kind of one of my points in a way, that the in a way the generative AI, it has moved really fast from this uh, point where it's like a, it's kind of new technology, and it's kind of in a way already exists as a commodity. In a way you can just basically start using it, but the point is that the kind of the rest of the world, it just takes time to kind of integrate to that capability now. But everything
Yeah.
will kind of happen, and it will have like an impact on everything,
Yes.
in some ways. And one example is that, for example, the data analytics space that I'm at the moment, I'm trying to have this project where we kind of have a client, and then we are trying to build this kind of like analyst as a service, which is basically just a generative AI agent that knows that there are few database tables that are kind of specifically tailored for answering some set of questions, and they are relatively simple, so the AI can handle those. But it can kind of still, for someone that doesn't know SQL, and then the generative AI can actually write SQL, and it can actually write those queries really fast. And we can ask questions like, uh, it's like this sports league, so we can ask questions like, who was the first scorer in this specific season, and who made the first 10 goals in 10 games, and like questions that are really, would be really, really time consuming to answer by hand, basically. And the AI can do that, like super fast, and it can basically be an take an analyst role at the moment.
Yeah,
Actually,
that sounds really like a next step. I was thinking, super metrics, super metrics. Santeri for sure. You know them. So like the same idea, but this kind of supermetrics could be your way of integrating or actually extracting that data, because you mentioned as an example SQL. So SQL database is structured data, but also kind of the idea is the same, right? That the more you have data sources from that organization, then of course, the more use cases you can serve, and they can do studies where you kind of, or analysis where you would combine some in-house
yeah,
data from CRM or your e-commerce database, and then with Google Analytics, for example, or whatever API connections you have, Google Ads, Meta Ads, and that actually brings this super intelligence into it, because for human, I know, having done those analysis, it takes time. Again, a lot of clicking, a lot of thinking, a lot of and merging that data. Even if we have things like supermetrics, it takes time because you need to sort of create in Excel or Google Sheet the template, and which will be then populated with the fields and so on. So I can definitely see the value in that, and it's sort of like the next step and in the evolution of analytics. So we had these aggregators like supermetrics. So now, like you said, the logical step is that we have this um, analyst as a service. And that nice the Clipper bot. You have the
yeah,
Clipper bot, and then you talk to it, and it will actually tell. And it probably would make the analytical process more enjoyable for more people, right?
yeah,
Because I mean, I think people like you and me, we kind of can cope with that kind of uh, the tables and the tools and the platforms. We kind of like it, but we are, let's say, a little bit outliers in the sense that not all people would enjoy
yeah,
that. And even for us, we would definitely, if there was a way, we could do more, because we could ask more questions, and we could think more about, the actual analysis. So it's actually good analogies with the data science. Like last week, Tommy was talking about, the 80% of the data scientist's job time goes into the pre-processing. So it's the
Yeah.
same in the analytics. Like 80% of our time goes into logging to these systems, clicking on the reports, customizing the reports, and then yeah, maybe only like 20% or less actually goes into creating the questions and doing the thinking and the interpretation. So this can really revolutionize the stuff because really there's a lot of redundancy and transaction costs in terms of searching the information and putting it together. I think this could really be huge.
Yeah, yeah, I think so too. I think that one of the difficulties, I think, and this is not just with the AI, but I think it kind of uh, it's it's amplified when we add the AI. But the difficulty is that we have too much data basically, and we have too complex data structures. For example, if you mentioned the Google Ads, like if you go, you use tool like Google BigQuery, and then you do the Google Ads data extraction to the BigQuery, and then you go to actually see what the structure of the data is. And even if you're an experienced uh, data scientist, it would take you hours to actually understand the data structure. It's just so complex, complicated. And then if we would believe that, okay, now we just add the AI, and then the AI would be able to answer uh, because we can't answer ourselves, basically, then I think you would have a problem because the AI would likely make mistakes, but the AI doesn't know that it makes mistakes. So
Right.
the problem with AI is that it doesn't know the limits of the knowledge, right? It doesn't really have this concept of knowledge in a way. It just basically predicts that this is kind of the right thing, and but it
Mm.
doesn't kind of have this. We have this kind of this idea of something being true and something being kind of false, but the AI doesn't kind of have that idea in a way. It just predicts, and it's more often right than wrong. But then once you kind of make it more difficult, like you increase the difficulty level, then it starts being wrong more often than right.
Right.
But it doesn't know that. And then if you are kind of, you just use it and it's very convincing. Okay, this is the right query, this is the right answer, and then
Yeah.
you end up with lots of bullshit basically. So you need
Yeah,
to,
yeah, yeah, yeah,
yeah,
sure. But you know, a couple of good things here are that the context windows are
yeah,
nowadays already like huge, so you can
yeah,
fit in a lot of structured data. And then,
yeah,
of course, as you mentioned, the RAG approaches, like in the case for students, uh, like who don't know what RAG is, so RAG retrieval augmented generation. Um, I think it was mentioned in one of the earlier lectures, or at least in the lecture notes. So this is the approach that Santeri was explaining, which is that all this chunking um, of the material and creating the embeddings, and then
yeah,
retrieving them using this vector similarity um, is for is old idea, but for the LLM systems, it's now that they can narrow down the space of the relevant like content basically. So the text could be huge. We have the company database of some information. It could have thousands of pages of manuals or whatever. So the LLM need to locate what is the relevant, most likely most relevant information for the prompt for the question that the user is asking, and then it extracts some kind of uh, some number of that content that is similar to the person's query, and then it uses that as a context. It adds it to the system prompt basically to provide the answer. So it will get like all the hard like raw text, but then it will write it up in a user-friendly way as an answer to your question. So that's the RAG based approach, which is currently like the current approach of using LLMs. Instead of us always fine-tuning our own approach, we use the RAG to extract information. So this is another thing which is useful for like the vision that you're saying, Santeri, because I guess you just need maybe you'd need like data dictionary or something like a middle, mid layer to help the explain the structure. Even though it's pretty good, the LLMs are even pretty good at interpreting variables, and like you mentioned BigQuery documentation. They would I would argue that their understanding of structured data is actually pretty good, natively as well. But of course, would need to be tested. But what I'm saying is that the probability of hallucination is much less, at least when I've used it with structured data, because it has like much less to room for hallucination because it's coming from the structured data, the answer through the
Yeah,
RAG process. But one thing which you mentioned is, of course, user trust, and then how to kind of how to show in the response where the information is coming from, right? Because if it is mixing something in a
yeah,
wrong way or doing some kind of step this is wrong, like somehow showing the maybe the source, information, like kind of like the source variables or source tables together with the output. So some tricks like this, for at least for a trained eye, to see that okay, it was searching for the here are right metric CTR, and here's the window is the past 6 months. And then you could see that okay, it kind of makes sense, right? Because sometimes even the window in web analytics, right, it depends. Sometimes we want the past week's data, sometimes 3 months, sometimes even lifetime. But if these kind of choices are not predefined, but anyway it has to do them, then just show them in the output. So then a trained eye can see that, oh, okay, you used only 3 months data, I want 6 months data, and then okay, redoing and then repeating the process. So transparency could address the risk of hallucinations.
yeah, yeah. I agree. In the example that I kind of mentioned, that the kind of the analyst as a service or AI analyst approach, I think the idea is that it kind of creates these really complicated queries in a way that you can actually retrieve like series of events, like for example finding a player that has scored or made a point in 10 consecutive games, and then maybe even ordering players based on the who has made most scores in 10 games in a row or something like that. It kind of produces these really complex queries, and for someone that's not doesn't really know SQL or SQL, that's how it should be pronounced, then it's really difficult to kind of interpret that, uh, is this kind of the right query or not, in a way. But I think that, like you said, there are few answers. That one answer is that okay, the kind of the capabilities of the AI, it's actually pretty good. The context windows, we can kind of load stuff there, and then the AI can output, okay, where did you come up with this answer, and so on. But then I think one approach, what I've been using now for this purpose, is that I actually create like a specialized views for the AI, because we have kind of previously discussed with the client that, okay, these are the use cases, these are the types of questions that you would be asking. Then we kind of create this specialized view just for the AI, which allows those use cases to be answered. And then we kind of remove all of the other stuff from the view. So then the AI can kind of just have the stuff that it needs, and then when if someone tries to use it for some other use case, then it just basically it's out of scope for this. And then if we want to add new features, then we could start experimenting. Okay, what happens if we add a new view that would allow some other questions to be answered? But I think the results would be like a lot worse if we would just dump the database and say that, okay, now AI, your role is to answer questions, because then there are these all kinds of like hidden things that the AI doesn't probably know, and it starts to make mistakes, and then those mistakes would not be visible right away.
Do you think this would be a case for fine tuning? Because I've been like I haven't been involved in any LLM fine tuning just because the RAG has always worked out really well. And yeah, then you also have the possibility of like running custom GPTs, or which is basically the same as you just developing your own chatbot because you could change the system prompt.
Yeah.
But in like if you don't want to develop anything, you can just create a custom GPT and then give it, instructions which will be always part of the system prompt. And for students, system prompt means like what the LLM is instructed to do in the background. So when you use ChatGPT, it always has a system prompt, and the system prompt tells it basically how to approach your question. So it considers your question, but it also considers the system prompt. So the system prompt contains things like safety, uh, guard, uh, safety guidelines, and guardrails. So like what not to say and what to avoid and things like that. But it's hidden there. We don't know. But if we build our own system, our own chatbot, we can kind of create our own system prompt. And of course, still, if we use an LLM API connection to OpenAI, for example, then those guardrails that they have and their system prompt will still affect the final output. If we would use something that's totally like system prompt free, like an open source LLM, then we would have total control and we could generate whatever, even toxic material or curse words or whatever. Um, so, but in general, there is a system prompt. So the question was that do you think this would be a case for fine tuning instead of like adjusting the prompt? By this I mean that take all the documentation of Google Analytics, take all the, well, SQL you don't need, but let's say we have these analytic systems like BigQuery and Google Analytics and Google Ads scripting language also. So those are kind of specific and they go beyond the understanding of the vanilla uh, LLM. So, but yeah, it's a question if we should put them in a huge corpora and just fine tune. Have you fine tuned any? Did you ever find a good use case to fine tune an LLM?
Uh, well, I have like followed the process and kind of for testing purposes, but I think the key here is that what you want to achieve with the fine tuning. That's a trade.
Right.
You kind of trade generality to specificity, right? You kind of fine tune
Yeah.
the model to do something very specific. What you can also do with the more generic, but by just providing like you can do this few shot prompting. Even with the API, you can kind of provide this chat message history and do this few shot prompting technique that you can kind of train the
Right.
model on the fly. But so you can, I think what you can achieve with fine tuning, you can achieve with other tools as well. But
Hmm.
then once the kind of the if you have something that's really like popular and people use it on a daily basis, and you are looking at if you're using OpenAI and you are looking your OpenAI invoice, and it says that you are now spending 1 million euros per day for these customers that are making API calls, and maybe you're still making a profit. They are paying you 2 million a day, but you are paying 1 million for OpenAI. But then if you would actually use the fine tuning, you would now let's say you are now using GPT-4, but you could achieve the same performance with fine-tuned GPT 3.5, but with tenth of the cost.
Right.
Then you would have a use case for fine tuning, basically. And I think that's the kind of the main point. If you They are like examples that people have published that they've been able to train, for example, open source models.
Mm-hmm.
They've been using GPT-4 or Claude to generate
Mm-hmm.
these training data, and then they've been using
Right.
open source models to just basically have same level of answers as GPT-4 or Claude in certain context, but with fraction of the cost because they're just running some smaller open source model on their own hardware.
Oh yeah, that's hacking the cost. Yeah, that's pretty cool.
But I think that's really important in a way, like the synthetic data, basically, that we can actually use these GPTs to generate synthetic data, and it's a danger. There are
Yeah.
these problematic aspects as well, but I think there are also like good use cases for that.
Excellent. Yeah, no, but I love your new idea with the analyst as a service, and I'll be very curious to I'll stay I'll keep following you on LinkedIn and to check any news on that. But yeah, I think it's really needed. Um, okay, that's pretty much all from my side. I really enjoyed this. I learned a lot of new things, and Santeri gave a really fresh, I think very novel angle. At least it opened like kind of my eyes. So if no more questions from other people, then I would like to thank you, Santeri, for this, and uh, wishing you all the best with your projects, and let's stay in touch, and have a great rest of the year. Enjoy your Christmas time and so on.
Yes, thank you. You too.
Excellent. Bye.
Yeah. Bye.